Pre-Calc lesson 2-1, linear and quadratic functions and modeling. So lots of stuff in here. So here we go. All right, polynomial functions. So you're going to look at these, and we need to make sure we realize what the leading coefficient and the degree is. So the leading coefficient is going to be the number in front. The degree is going to be your biggest exponent. So if the biggest exponent is 4, that's your degree, and then the number in front of that would be the leading coefficient. All right. So just some different types of functions. A linear function has a degree of 1, leading coefficient a. Quadratic function has a degree of 2, leading coefficient of a, so on and so forth. All right, write an equation for the linear function f such that f of negative 1 is 2. So our 2 points are going to be 2, 3, and negative 1, 2. So a linear function, first thing we got to find is slope. So 3 minus 2 over 2 minus negative 1. That becomes 1 over 3. So our slope is 1/3. All right. So then remember, we're going to pick a point. I'll just pick that one. Doesn't matter. And we're going to put it in point slope form. So y minus 3 equals 1/3 times x minus 2. We did a lot of this in chapter P. So then this is point slope form, and then to convert to slope intercept form, I would distribute, and then I would add 3. So y equals 1/3 x plus 2 and 1/3. So there's your linear function. All right, find the slope, put it in point slope form, and then put it in, solve for y to put it in slope intercept form. So there you go. All right, remember slope is average rate of change in y over change in x. If it's function notation, still the same thing, change in y over change in x. Constant rate of change means we have a slope of 0. So just some characterizations of a linear function: a degree of 1. We put it in mx plus b form. M is slope, b is y-intercept, and just some kind of increasing or decreasing type of things. All right, correlation coefficient. So when you're looking at correlation, that's your R value. So we're going to look at the first quadrant, and there's going to be a data set. If it's very, very centered around that line right there, that is going to be strong positive. If it's centered around that line right there, that is going to be strong negative. If it's kind of scattered all over the place, it's hard to tell, that's going to be, so this is going to be close to 1, this is going to be close to negative 1, and then that's going to be close to 0 when there is a weak correlation. All right. So if you look at these, there's some examples. That would be a strong positive. That would still be positive, but a little bit weaker than the first one. That would be close to 0. So that one I'd say very close to 1. This one's like 0.5 maybe. That one's really close to negative 1. And that one's like negative 0.7. Weak, or negative 0.5. You're just kind of estimating as you're looking at these correlations. Okay. So regression analysis, to find the regression, that's when we find use our stat mode. Remember, we can put our information in edit and go from there. We've done that a little bit before already. So when you get to those problems on the assignment, that's how you do them. All right, I'll come back to this and go through some examples, but we need to talk about quadratics now. Describe how to transform the graph into this. So we've got 3 things going on here. So we've got 1, that 2 out front. That's a vertical stretch of 2. Then x minus 2 in would be right 2. Then minus 3 out would be down 3. All right. That form is called vertex form. So we can write it in. This is standard form up here. This is vertex form right here. Okay. To find the vertex, we're going to use the old negative b over 2a formula. Okay. That's the h part of the vertex for hk. Then to find k, you take that and put it back into the function. All right, so you can change from standard form to vertex form, and that's kind of what we're going to go through here. So let's give that a whirl. All right, so use the vertex form to find the vertex and the axis of symmetry, rewrite the equation. All right, so we're going to go negative b over 2a. Well, what's the opposite of b would be 8 over 2 times a, would be 2 times 2 is 4. So 2 would be the h for the vertex. Then to find k, you're going to take that 2 and you're going to put it into the function. Okay, so you're going to go 2 times 2 squared minus 8 times 2 plus 11. And that gives you 3 if you do that. So the vertex is 2, 3. Okay, our a value is 2, so that's going to stay the same. So 2 times x minus h squared plus 3. That's the vertex form. This one right here is the standard form. They are the same thing on the graph. Okay? A value stays the same. Vertex form, standard form. All right. We got it right. Nice job. Let's try that again. It says use completing the square, but we'll use the vertex form. That good old negative b over 2a makes our life easy. So that'd be negative 12 over 2 times a would be negative 8. So if I divide negative 12 by negative 8, I get 1.5. So that is my h value. All right, to find my k value, I would take 1.5 and put it back into the function. I strongly encourage you to use parentheses when you're putting these into the function, especially when the numbers are negative. So negative 4 times 1.5, using my calc here, that comes out to be 1 if I put that in my calculator. Okay, so then to rewrite it in vertex form, we take y equals, a goes out front, so negative 4, times x minus the h squared plus 1. Vertex form, standard form, that's how you write the quadratic functions. Okay, and there we go. So some characterizations of quadratics. We've got vertex form, standard form, or vertex form on the bottom, standard form. That negative b over 2a really helps make our life easy. We got quadratic formula if we need it. So just some different things that deal with quadratics. All right, vertical free fall motion. We've already talked a little bit about this in chapter P as well, but that negative 1/2 times g. So if it's in meters, it's going to be negative 16 t squared, or excuse me, in feet, it's going to be negative 16 t squared to start. If it's in meters, it's going to be negative 4.9 t squared. And then initial velocity and starting point as well. And we can graph those on Desmos. But let's go back now and I'll go through some of the assignments here, or some of the problems on the assignment. All right, here we go. 28 says, find the vertex and axis of symmetry. So here we go. So 28. I'm going to rewrite that in vertex form. So negative b over 2a. That's negative 7 over 2 times a would be negative 4. Negative 7 divided by negative 4 is 1.75. That is my h. Okay. Then I got to put that back into the function. .125 is my k value. So then to write the equation in vertex form, take a times x minus 1.75 squared, and then we go plus 3.125. So the vertex h is the axis of symmetry as well, but then that's how you do that. Let's try that again. 33, it says use completing the square. We'll use the vertex form, the negative b over 2a. So negative b would be for 33 now would be 4. Opposite of negative 4 is 4. Over 2 times a, our a value would be 1, so 2. So our h is going to be 2. Then I got to plug that in. And that also gives me 2. Okay, so then to write the vertex form, I go a, which is 1, times x minus 2 squared plus 2. All right, 43. Write an equation for the quadratic in vertex that gives a vertex and a point. So we need to find our a value this time. So remember, it's y equals a times x minus h squared plus k. So they gave us h, k, x, y. So y is 5 equals a is what we're looking for times x minus h, 0 minus 1 squared plus k is 3. Well, 0 minus 1 is negative 1. If I square that, I get positive 1. So now we have 5 equals 1a plus 3. Subtract 3. So our a value is 2. So now if we want to take and rewrite that equation, it would be y equals 2, that's our a value, times x minus h squared, because that's the vertex, plus 3. All right, 61. As a promotion, Houston Astros, competition is held to see who can throw a baseball from the upper deck, 83 above field level. The winner throws the ball with an initial velocity of 92 feet per second, and it lands on the infield grass. So find the maximum height of a baseball. So from the front, so 83 is our starter. We're in feet, so we're going to go negative 16t squared plus 92t plus 83. Okay, so the max height of the ball, let's just graph this thing. Negative 16 squared plus 92t plus 83. Oops. Put that in terms of x. There we go. So let's go back to the home. You can see come on, boom, right there. That's the maximum height the ball is thrown. So about 2.875 would be the seconds, 215 would be the height. So the maximum height would be about 215 feet. How much time is the ball in the air? Well, that would be the throw, then it would land right here, which would be at about 6.5 seconds. So 6.5 seconds, the ball is in the air. Okay.